So we're going to get started right away here. First off, any questions that you guys have from the homework? I'll pause the recording though for now. So number 18 from the homework. Number 18 from the homework. This was where we left off kind of yesterday. We'd said that, all right, log base 3. So if I can write the inside as 3 to a power, I can get my answer. So looking at this, if this was log base 3, I'll make this a little bit bigger, easier to see. Log base 3, this is from the homework, number 18. A little bit farther than I think I said you guys needed to go yesterday. But log base 3 of, okay, 9. Is everybody good with 9 being 3 squared, right? So 3 to the second power. But the fifth root right here would mean that on the bottom of that 2, I'm dividing by 5 as my exponent, right? 2 over 5. So I can rewrite that 9 inside of fifth root as 3 to the 2/5 power. These two match, log base 3 of 3. And again, everybody, this is a nice connection for where I'm picking up today. So are we good here? That if these match, log base 3 of 3 to the 2/5 power, that 2/5 power is my answer. Okay, the 2/5 power is my answer. We're good there. The trick was that some of the things that you're going to encounter don't work out that nicely. I can't rewrite the thing inside the log as the base power. So let's see here. We had stopped in the notes. Yeah, we'd stopped in the notes at number 12. And we just done one where we said, okay, instead of trying to do the mental gymnastics of rewriting, okay, what power of this makes the thing inside? What if I just turn it into an equation? What if I just turn it into an equation like what we were seeing before? And that's why these are on the same page of your notes, because they are linked. They are the same thing. So let's do number 13 here. Actually, 13 would be like the one we just did, okay? 13, there is nothing wrong with doing this one with rewriting the fourth root of 27 as 3 to a power. But if you really didn't want to, you could even make this into an equation. You could make this 3 to the x power. What power of 3 makes the fourth root of 27? So you could write it as an equation, and you're going to have to do that on some of the ones today. This one, you could do it the other way, that we just looked at that previous problem. But I could go ahead and say, okay, well, this is 3 to the x power equals 27 is 3 cubed. And the fourth root means that my exponent is over 4. The third power makes it the 27. The fourth root is the over 4 part. So then this would become just x equals 3 over 4. Notice how, again, our original problem doesn't have an x in it. So really, we're just saying that my answer is 3 over 4. That log base 3 of the fourth root of 27, the answer is 3 over 4. So the number 14, this is one where that would be kind of hard to write that. You could probably do it, but it's going to be easier, I think, for most of us to go ahead and rewrite this as an equation. 1/2 to some power is supposed to equal 16. What power of 1/2 makes 16? Well, let's write both of those as 2 to a power. So is everybody good with the 1/2 being 2 to the -1 power? Right, that's what 1/2 is, 2 to the -1 power. The x then is multiplied by that. 1/2 times, -1 times x. 16. 16 is 2 to the 4th power. So really, I get -x equals 4. So class, what's x then? -4. And again, you can think of that as multiplying by -1, dividing both sides by -1, or just saying if I know what -x is the opposite of that. So x is -4. Again, 15 is right on the edge. You could do it either way. I could write 15. Let's do this one the old way one more time so we see that again, because I want you guys to have as many tools as you can for solving these. So this one, let's just see if I can write it as 3 to a power. Log base 3 of 3. How do I get 9 out of 3? 3 to what power makes 9? So I heard a 2 and I heard a negative, right? Because it's 1 over 9. Is everybody good with that? So this would be -2. What do I do with the 5th root? Underneath the -2, the 5 is my denominator. So log base 3 of 3 to the -2/5. My answer is -2/5. Or again, if you wrote this as an equation, 3 to the x power equals 3 to the -2/5 power. Either way, answer is -2/5. (16) If there isn't a base, what is it? 10. So this is log base 10. So let's do it this way. 10 to some power is supposed to equal 1 over the square root of 10,000. Well, 10 to the x power then. Can I write that? Can I write 10,000 as 10 to a power? So what power makes 10,000? 10 to what power makes 10,000? 4. 1, 2, 3, 4 zeros. So this is 10 to the 4th power. What makes it 1 over that? A negative. And what do I do with that square root? Yes, specifically over 2. Now this one, wait a second. -4 over 2 reduces. What's -4 divided by 2? From the square root. The square root is a 1/2 exponent. Does that make sense? They just don't write the little 2 for square roots. So this reduces just to -2. Does that make sense to everybody? The reason that happened is I can take the square root of 10,000. The square root of 10,000 is 100 times 100, or 10 squared. So either way, I'm going to get x is equal to -2. Or again, just the answer is -2. 17, I wouldn't want to do with the old method of trying to say 25 to what power makes this. I would definitely make an equation here. 25 to the x power equals 5 to the 1/3 power, right? That's a cube root is a 1/3 power. So 25 is 5 squared. So 5 squared times x equals 5 to the 1/3 power. 2x equals 1/3. Now this was throwing some people off in the last class. What am I going to do here to solve for x? Divide by 2. How do I divide 1/3 by 2? Multiply the bottoms. Or you could even rewrite this as 1/3 times 1/2, if that made more sense to you. Either way, it's going to be 1 over 6. And then the last one like this is number 18. Natural log means log base e. Let's just go straight to an equation. E to some power equals 1 over the cube root of e to the 7th power. So e to some power equals e to the, I'm not going to have enough room to write there. I'll write it down here. E to the 7th power equals e to the, going too fast. Sorry, guys. Let's try that again. E to some power, not the 7th power, e to some power equals, erase that one. I put the 7 on the wrong side. E to some power equals e to the 7th power negative, because it's 1 over that, divided by 3 because of the cube root. And that is my answer then. X is equal to -7/3. So at this point, you should be set to do that whole front page of the homework, I believe. Everything numbers 2 through 24. You should be able to do 2 through 24 at this point. So let's do that. I'm going to give you guys 5-8 minutes to work on those and to ask any questions you have. Again, I'll come around, Emily will come around, we'll check. Please ask, get as much of this done as you can. And then we'll move on to what's going on that last page. Before we move on here, any questions from the homework from numbers 14 through 24? Any of those that anybody got stuck on that we need to go over? Yeah, 24? Okay, so everybody take a look at 24. I'm gonna have you guys help me out here. So first off, I need to know what that ln means, right? That's what the initial bit here, this is ln. What kind of log is ln? Natural log, and what does that mean the base is? E. So let's rewrite this. Log base E of 1 over the cube root of E squared. So once we've got that, let's go ahead and write this as an equation. So how do I write this one as an equation? Nick, how do I write this as an equation? Yep. You could, yes, you could do all that, or you could, to start off with, just copy down what's already inside the parentheses. Like you don't have to start that, you're already on the solving part. So I'm going to write it just exactly as it is right now, so everybody sees that that is the equation representation of a log. In fact, everyone, now might be a good time to show this. If I just say I'm looking for X, everybody's full attention up here, because this is going to come up more and more often as we go on. If I just want to say, oh, I'm setting this equal to X, I want to know what X is, that's my answer. There is a very specific pattern for how you switch from log form to exponential form. And this is actually going to show up later on in the notes as well. But I'm going to give it to you now in case you want to use this tool now. If I have log base B of A equals X, the base comes down, whatever I'm equal to is my exponents, and whatever was inside the parentheses is now what I'm equal to. This is essentially what we're doing right now. We're taking that log and rewriting it in exponential form. And again, that is what a log is. It's a rewritten form of an exponent. So here, we've already set that up. E to the x power equals what was inside the parentheses. Now, what Nick was starting to do is rewrite this as e to some power. So let's do that piece by piece. What's something that's going to be up in the exponent for this e? It's not here today. Joey, what's something that I'd put here? Like one piece of it. You don't have to do the whole thing. Okay, so we're going to need a 2. Is everybody good with that? We already had a 2 down there. I'm still going to need a 2. But it's not just 2. Saul, what else is that 2 going to need?
You're going to need 3 in front.
So 2 over 3 to represent the cube root. And then what's the last piece? Alyssa? A negative. Technically, you can put the negative anywhere on that fraction, but it's easiest to put it on the 2. And do we all see our answer now? The e's match. X, or the answer is -2/3. Done. So the whole thing of today's and yesterday's lesson with section 3 is just a whole bunch of different ways to solve these things. And the trick is that there's a bunch of different equations that you can solve. So right now, we've seen exponential equations where it's like something to a power equals something to a power. We've seen a single log that we can rewrite as an exponential equation. Look at the next page of the notes now. Go back to the notes and go to the second page. What if I have logs on one side or both sides of an equation? It's actually not bad. In fact, it's almost identical to what we were doing before. So if I have log of a base of something equals log of a base of something, if the log and base match, if they are the same, I can ignore them, just like I was ignoring the base of the exponents on the previous set. So here it says if I have a single log on both sides of the equation with the same base, you can drop the logs. Like you don't even need them, ignore them. Rewrite it without it and solve what's left. Again, I don't know if this helps you guys at all, but second period had some questions about like, why are we ignoring those pieces? What are we doing with them? Are we canceling them? So we're not actually canceling. We're just saying we don't need to worry about them. Everybody's hopefully good with the idea of an equation being balanced, like both sides of the equation match. So if you're trying to match somebody else and your shoes and pants already match, you can ignore that part and focus on the tops, what you have to match there. Does that make sense? I tried to do an analogy in second period and it fell flat. I don't know. Apparently Sadie Hawkins, people don't match for Sadie Hawkins anymore, or maybe they do. The dance that happened already, like when was Sadie Hawkins this year? Last semester? Okay, last semester. Oh, we were apparently, second period at least had some people that remembered when it happened. Last, yeah, so. Or was it February when I was out? That was probably what happened. I don't remember it happening, but I'm pretty sure it happened. So I brought that up in second period because of the whole matching thing, and half the class just stared at me. Apparently not everybody matches for Sadie Hawkins. So now that we've had that little tangent back here. So number 19, log base 2 of 5x equals log base 2 of 100. Are we good with the fact that the log base 2's already match? So I can ignore them. And all I need to have happen is make sure that the 5x matches the 100. As long as I can make those match, we're good. So nice, easy one-step equation. Divide both sides by 5. We get x equals 20. Super simple. Number 20, same idea. Log base 6, log base 6 already matches. You can ignore them and just look at the x over 3 equals 11. How do I solve this one? Multiply both sides by 3. So times 3. I am not, okay, and as a quick side note, I'm not canceling the logs out. I'm just ignoring them, saying they already match, I don't need them. Here, when I multiply both sides by 3, those 3's cancel. Does that make sense? I'm actively getting rid of one of them by doing its opposite. And so this becomes x equals 33. There's my answer. Next one, we've got log base 3 on both sides. Those match. Do you want to copy the notes? Do you have? Okay. I've got extras back there. So at this point, log base 3, we can ignore those and just do 2 to the 3x equals 64. Ooh, sneaky. They put one of the problems that we were just doing inside a log problem. Does that make sense? Like what we're looking at right now is literally the same kinds of problems we were solving yesterday. So let's rewrite them as both 2 to a power, 2 to the 3x. 64 is 2 to the 6th power, right? 2, 4, 8, 16, 32, 64. So now I can just say 36, or sorry, 3x equals 6. I don't need the 2's because they already match. As I'm walking along, as I'm doing this process, every time I've got a piece that already matches, I can ignore it and focus on the part that doesn't match yet until I can solve it down to figure out what the missing piece is so that they match. So here, divide both sides by 3. X is equal to 2. For 22, yes. So if the base, like here, if the bases don't match or if the logs don't match, I will teach you how to solve that in like sections 6 or 7. So for right now, all the problems we're doing are matching bases. Does that make sense? But there is a way of doing it. It just takes a little bit more work and often involves a calculator because you'll get answers that aren't nice. They're long decimals going on forever. But you can solve those, and I will show you how to do that probably next week. So 22 log base 3 of, or sorry, log base 5 of 3x plus 15, log base 5 of 4x plus 7. We don't need the log base 5s. We just need 3x plus 15 equals 4x plus 7. I can subtract 3x from both sides. My equal sign doesn't look like an equal sign. 15 equals x plus 7. Add 7 to both sides. Sorry, nope, subtract 7 from both sides. And we get 8 equals x. So at this point, you should be able to do a good chunk of the problems on the back page of the homework. So let's do that right now. Let's take 5 minutes. Everybody do at minimum 26 and 28. You should be good to do 26 all the way through 32 for now. 34 may throw you off because I haven't shown you that yet. So start with 26 and 28. Fine. So we just said we can set x to the 4/3 power equal to 16, but I can't make those bases match. So instead, I'm going to raise both sides to the 3/4 power like we did back in unit 6, because that way the 3's cancel out, the 4's cancel out. X is equal to 16 to the 3/4 power. This is the only one like this on the notes. There's only one, I think, like this on the homework. It's a review of what you did back in unit 6 of saying, if I have x to a fraction power, I can get rid of that fraction power by raising it to the reciprocal because those multiply, and 4/3 times 3/4, everything cancels. I'm left with just 16 to the 3/4. I can reduce that though. Probably the fastest way of doing this is let's go ahead and write that 16 as 2 to the 4th power raised to the 3/4 power, so that when I multiply those, 4 times 3/4, the 4's actually cancel out, and I end up with just 2 cubed. 2 cubed, or 8 is my answer there. 8 to the 4/3 power equals 16. Yes, 16 to the 3/4 power, which again, I can rewrite that 2 to the 4th for the 16. And then the 4's cancel out. I have 2 to the 3rd or 8. Those are both fine. 2 to the 3rd power or 8. Again, that's with raising it to the reciprocal. Okay, so they keep throwing different kinds of problems at you. So here's the last type that you're going to see. What if there's only one log? Well, there's a couple options. One is to switch it to exponential form, like what I showed you just a minute ago. This 32 comes down, 32. Whatever I'm equal to becomes my exponent, 32 to the x power. Whatever's inside the log becomes what I'm equal to. 32 to the x power equals 8. So now 32 to the x power equals 8. I can write that as 2 to a power on the left, 2 to a power on the right. So 32 is 2 to the 5th power times the x that was already there. 8 is 2 to the 3rd power. And then I can set the exponents equal to each other. 5x equals 3. I don't need to worry about the 2's because they already match. Divide both sides by 5. X is equal to 3 over 5. Does that make sense to everybody? X is equal to 3 over 5. 26, same idea. Bring the 5 down. 5 to the 0 power, whatever's over here, this becomes my exponent. And I'm equal to whatever's inside the log, 3x minus 14. Well, 5 to the 0 power. What's anything to the 0 power? 1. 1 equals 3x minus 14. I'm not going to show all the steps for this. Add 14. 1 plus 14 is 15 equals 3x. Divide by 3. X is equal to 5. Hopefully everybody's good with that two-step solving. Number 27. This one's actually super easy. Rewrite it as log base e, right? That's when you see natural log, think log base e. Log base e of x. Nope. Oh yeah, log base e of x equals 5. E comes down. What I'm equal to is my exponent. Whatever's inside the log is what I'm equal to. That's my answer. X is e to the 5th power. There's no other work that you have to do there. I would prefer you to leave it like that. X equals e to the 5th power. 28. 28. Log root 5th root of 1000 equals x. Wait a second. Do I want to switch this? If I switch this, I'm going to get 10 to the x power. I'm going to get my x stuck up in the exponent. I just want to simplify this. It's already solved for x. X is by itself. So I just need to say, well, this means log base 10 of the 5th root of 1000. So log base 10 of 10 to the 3rd power over 5. Right? 10 to the 3rd power makes 1000. The 5th root of 1000, that 5th root means 1 over 5. So log base 10 of 10 to the 3 over 5 is x. That means x is just 3 over 5, just the exponent. Right? The 10s match. The exponent is my answer. So if it's already solved for x, don't mess it up. Don't switch over to exponential form and get x trapped. 29, last two examples. Log base e. Log base e of x minus 4 equals 3. E comes down, e to the 3rd power equals x minus 4. And just add 4 to both sides. Plus 4, we get x is equal to e to the 3 plus 4. Leave it like that. That's how I want to see my answer. And then the last one, this one's actually, so there was two like this. This one's going to be x to the 2/3 power equals 16. Raise both sides to the reciprocal power. 3 over 2. 3 over 2. That way the 3's cancel out, the 2's cancel out. X is equal to 16 to the 3/2 power And you have some options here. I could take the square root of 16 and raise that to the third power. I could write 16 as 2 to the fourth power and multiply that 4 by 3/2. That'd maybe be a pretty simple way of doing it. 4 divided by 2 would be 2, times 3 would be 6. 2 to the sixth power. X is equal to 64. 2, 4, 8, 16, 32, 64. All right, that's the end of the lesson there. Your homework again is numbers 2 through 40, 2 through 40 even, and you guys have 10 minutes. 10 minutes to get a good chunk of that done. So let's work on that, try to finish it. Some of you are going to be done before the end of class.